Okay, so we already went over the derivative of sine, so now we're going to look at the derivative of cosine. So instead of deriving it, I just gave you the rule. You can look online to see how to derive the formula or rule for when you have to take the derivative of the cosine of x with respect to x. It is indeed negative sine of x. All right, so here we go. I know it says B here for my example. Let me just put example. The reason this says B is because there was a part A and the do now. They actually don't have a relationship between them except that I'm asking you to find a derivative of equations in which the expression in it has either sine or cosine. In this case, cosine and sine. So let's take a look at what we have here. The equation y equals the cosine of x over the quantity of 1 minus the sine of x. So here we go. Since it's one over the other, we need to do the quotient rule. So if I take the derivative on the left-hand side with respect to x, I'm getting dy over dx. If I take the derivative on the right-hand side with respect to x, and start to do the quotient rule. So bottom, the derivative of the top, which we now know as negative sine of x, minus the top times the derivative of the bottom, which is going to be negative, and the derivative of sine is cosine of x. By the way, the derivative of 1 is 0, so we don't need to write that. Okay, so bottom derivative of the top minus top derivative of the bottom over the bottom squared. Okay, so at this point, let's just figure out what we have in our numerator. So if I distribute the sine of x, and I distribute this negative sign to here, I get a positive cosine squared of x. And you should identify that there is an identity in the numerator. And this right here is 1. So we have 1 minus the sine of x over the quantity of 1 minus the sine of x squared. Uh-oh, I missed an n. That's supposed to be sine. So since that being the case, we can simplify dy over dx to be 1 over the quantity 1 minus the sine of x. That's supposed to be an equals. And there we have it. Okay, so we get to kind of go over quotient rule as well as the derivative of sine and the derivative of cosine. So this was a pretty decent example. We're going to do another one, but it's a word problem. Remember to make sure you get down the problem, work, and answer for each of these so you can practice them at home. So in this example, we have a bead hanging from a spring, and it's stretched 5 units beyond its rest position. And if that's the case, your rest position is when your position is 0. Okay? It's and released at time t equals 0. Okay, so then it starts to move because it's on a spring. It's going to move up and down. It says to bob up and down. Its position at any later time, tongue twister, is s equals 5 cosine of t. All right, so any time after t equals 0, s is 5 times the cosine of t. Okay, and even if you plug in 0, you're going to get 5 because it is stretched 5 units beyond its rest position. Okay, so everything should make sense in the problem. What are its velocity and acceleration at time t? Okay, all right, so velocity is v of t, and that's when we do s prime of t. So that means we need to do the derivative here. So it's 5 times the derivative of cosine of t, which is negative sine of t. So let's just clean this up. V of t is going to be negative 5 sine of t. okay? And they didn't give us at a particular time, okay, at an instant, so we're just leaving it as our function. Next, acceleration is s double prime of t, but is also v prime of t. So I'm going to take the derivative of v of t, and you can see how you need to know both derivatives. So be negative 5 times the cosine of t, because derivative of sine of t is cosine of t. And that's it. Okay, so even though it's a word problem, it's pretty straightforward. So good luck and do some more problems, and let me know if you have any questions.